more relevant once we are like pros at writing, not writing, at like solving differential equations, because then this is like where kind of the application comes in when we read a problem, recognize it as differential equation, write it as differential equation, and solve it. Fun stuff coming. But for now, I just want to get like the idea kind of in your head. So this is like a short little writing differential equations, woohoo! So review. A differential equation is, well, you have the definition like approximately 1 page ago, but we're going to do it again. Differential equation is, again, an equation that relates a function with one or more of its derivatives. So, I'm going to write it again, and you should write it again too, because repetition helps you remember things. An equation that relates a function with one or more of its derivatives. Coolio. Ooh, I haven't said that word in a while. I don't know where it came from. So, therefore, if we want to write or interpret a differential equation, this might involve us reading some information about a function and its derivatives and then translating it into math. So, we know that derivatives represent change, right? Again, old news, derivatives, masters. Therefore, when we write equations about how things are changing, it often ends up being a differential equation. So like, even that statement alone, you can start to kind of grasp, like, wow, differential equations must be everywhere and describe everything in our lives. I mean, low-key. For instance, we use differential equations to describe how populations change, how heat moves, how springs vibrate. So there's some physics, some bio, a little bit of chemistry. Like, dude, this stuff is just so cool. Oh my god, now there's video footage of me nerding out about math. I don't know how I feel about it, but whatever. Okay, for instance, the learning rate for new skills is proportional to the difference between the maximum potential for learning the skill, M, and the amount of skill already learned, L. So how do we write that in terms of math? Seems kind of hard, but it turns out that it's actually not, right? Because there's one word in this problem that gives us like this huge tip-off that it's gonna be like, oh, differential equation derivative. And that word is, oh, this is sad because you can't guess letters. Like you guess A, E, rate. That word is rate. Rate tips us off that we are dealing with a derivative, and that then if we're dealing with the derivative, we're probably dealing with some equation that is dealing with the derivative, and then we're like, oh, differential equation. So again, rate, keyword there. So the learning rate for new skills is proportional. So the learning rate for new skills. So learning new skills is going to be L. L equals learning skill. Learning new skills. You can make that whatever you want. L makes sense to me because L is learning. But you can use any letter. And then they tell us M is equal to the maximum potential. I'm just going to put max potential. Even though it's max potential for learning that skill, you have it right in front of you. And L is amount already learned. I'm just going to put already learned. So, and we know that it is proportional. So again, proportional means that it's going to be like something on one side of the equal sign equals and then a constant times that same thing. And then if it's inversely proportional, it's like something on one side of the equal sign and then equals, and then it's going to be like 1 over a constant, right? So inverse means 1 over the constant, and direct is just like, it's all on the same line. I don't know if that made sense. Hopefully you kind of followed. But anyway, so the learning rate for new skills. So not just learning new skills, which is L, but the learning rate. Rate, derivative, D, So the way we're going to write that is going to be dl over dt, okay? We kind of, I guess, assume that it's with respect to time. It doesn't explicitly say it, but that makes sense, right? The learning. Oh no, we do know, because rate, respect to time. So, the learning rate for new skills proportional to time is directly proportional to, so is means equals, is directly proportional to the difference, subtraction, between maximum potential for learning that skill, which is M, and the amount of skill that already learned. So the difference between M and L, which we can write as M minus L, or M minus L. So, there is how we write number 1 in terms of math. Okay? So let's think about number 2. I'm going to switch marker colors because I'm feeling spicy. All right? So, a puppy gains weight, W, so they're telling us our variable, so W is equal to puppy weight at a rate approximately inversely proportional to its age t, so t equals puppy's age in months. Okay, so they're saying a puppy gains weight at a rate. That's hard to say. A puppy gains weight at a rate. So we're looking at the rate of the puppy's weight gain. Rate, derivative with respect to time, dw over dt would be the way that we would describe the rate of the puppy's weight changing over time. Is inversely proportional. So again, we know we're going to have a fraction k over t. Okay, so I think I messed up the directly and indirectly proportional thing when I said it earlier. But this is right. So yeah, I did mess up when I said it earlier. So the directly and indirectly proportional thing can get a little tricky, and I will brush up on that and get back to you. And we'll go over it more once we actually have to like start writing and solving and doing like big